Hello everyone, this is Ketisha. In this video, I'm going to go through the AQA Physics Paper 1 Foundation Tier from 2025. Question number 3 is on the topic of atomic structure. Different isotopes, radioactive isotopes, emit different types of radiation. One type of uranium, U, decays into thorium, TH, by emitting an alpha particle. Which nuclear equation shows the decay of this isotope of uranium? Now, you wouldn't be given a periodic table. So how do you do this? Helium has a mass of 4 and a proton number of 2. So in all of them, helium is actually correct. So it's the masses that we need to look at. So the mass 226 plus 4, that adds up to 230. 90 plus 2 adds up to 92. Here, the mass doesn't add up. And uranium, thorium. Just seeing what's the difference between these two. So the third one looks correct, but the arrow is actually in the wrong place. Uranium is breaking into thorium and alpha particles, so it will be the first one. Figure 4 shows the percentage of uranium atoms in a sample of one uranium isotope varies with time. So it's an exponential graph. The percentage is decreasing as the time in days increases from 0 to 100. What is the time taken for 50% of the atoms of this uranium isotope to decay? Now 50% is actually the half-life. So 50 is going to be there. That's 20 days. What is the half-life of this uranium isotope? That will be 20. Figure 5 shows how the percentage of uranium atoms varies with time for 3 different isotopes of uranium A, B, and C. So you have uranium from 100, it takes up to nearly 30. Okay. Isotope B and C. Which isotope is the most unstable? Now, the most unstable is going to be dropping, the percentage in will drop much faster. So let's say at 5 days, isotope B is at about 40. About 5, isotope is about 90 or 88, and isotope C is at 60. So that would be isotope A. Reason: it has the shortest half-life, or you could say the graph is also the steepest or decays the quickest. Figure 6 shows the nuclei of 4 different atoms, A, B, C, and D. So you have the protons and the neutrons marked. Which nucleus in figure 6 has the smallest mass number? Smallest mass number is going to be the total number of protons and neutrons. That would be A. Which nuclei in mass figure 6 has an atomic number of 4? Atomic number is equal to the proton number. That would be D. Which two nuclei in figure 6 are isotopes of the same element? That means they should have the same number of protons, which is B and C. They have both B and C, right? Since they have the same number of protons, And you could say and different number of neutrons, but it's not necessary. Scientists have replaced old models of the atom with newer models. The new nuclear model of the atom has a nucleus at the center. Which model of the atom was replaced by the nuclear model? That would be the plum pudding model. So this was the first model, tiny spheres. The second model, the plum pudding model. And the third is the Bohr model, which is the nuclear model. What does the nuclear model state about the mass of an atom? The mass of the atom is concentrated in the electrons. No, it's concentrated in the nucleus. That brings us to the end of question number 3, and I will see you in question number 4.